So I was given the opportunity to talk a little bit about quality control and quality assurance. Now, as a previous colleague of mine used to say, how long is a piece of string? And I find that this is one of those topics. How far do you go? What do you measure? How far do you control? And you'll probably realize from the talk that it will be different for different clinics, and it's something that you need to work out for yourself as a clinic, and in terms of the protocols that you want to establish and the quality of the type of control that you want to run in your laboratory. Now, as an outline, just briefly, we will look at the common things that we measure in the lab, and why do we measure them? How do we decide on these type of measurements? What type of devices do we use for measuring the things that we want to find out? And then, slightly controversial, who does the measuring and how do we do the measuring? A little bit about the finer points on that. And then ultimately, what are we doing with all these results? I think we live in an age where we get a lot of information from all over us, and if we don't actually utilize this properly, it's actually a waste. So we don't want to eventually waste our time, but we actually want to do something constructive with all of this information. Now, first of all, in terms of the type of measurements that we use, I will definitely not be able to monitor or mention everything that all the labs do, but these are a brief few points that I want to highlight, and it's probably somewhere within this that you will recognize the things that you do in your own laboratory. Some will definitely do more of these measurements and others may do less than these type of measurements, and that again is dependent on each individual clinic. If we look at CO2 measurements, that's probably one of the very common ones that a lot of us do in our incubators as well as IVF chambers for those that work with it. I think within Europe it's not that common to work in IVF chambers. You see that much more often in the States. For those of you that are not familiar with the concept, it's an enclosed box where you have a CO2 atmosphere in which you can work, so you don't have the need to work with buffers outside of the incubator. So you also need to check that the CO2 measurements within that chamber is at specified typically 6% as you would get inside your incubator. And then the incubators themselves, as you pretty much know, there are so many different types of incubators on the market nowadays. We have our traditional type of incubators, the box types, that may have a port on the outside that you can just stick an analyzer on, or for those people that still use something like a FireRite, which I wouldn't necessarily recommend because of its accuracy. But then you get the benchtop incubators. Some of them are more difficult to actually measure because they are maybe not designed for that specific measurement. Some people that are using time-lapse systems like the embryoscope, these are other integrated systems that you can measure as well. But again, it depends on the type of equipment that you have on how you will do these measurements. Temperature is another big part of our daily routine and the things we measure in the laboratories. And that will range again from our incubators, different ways that we do the measurements there with external thermometers that's included inside the incubator. Heated stages, and again, whether that is the stages where you do your egg collection or whether it's a stage from where you do an embryo transfer. ICSI stages, these are quite often some of the black sheep in the family because they are more difficult to measure, a lot more variables, they are much more exposed, so therefore you can get much more variation there, but very, very important. Hubert alluded yesterday to the fact that oocytes are a very critical step within the IVF process, and when you are doing an ICSI and working with these oocytes, we have to take very, very critical care. And when we talk about heated stages, that's one of the times where the oocytes are exposed to a lot of heated stages during the egg collection, during denudation if you do ICSI, fertilization check the next day, and during ICSI itself. So a lot of times that you have to be very careful about measuring these temperatures. Warming blocks and ovens, another place that we have to measure when we do our follicle aspirations. We typically get our tubes into these blocks, make sure that we regulate the temperatures correctly there. A lot of laboratories make use of buffer media that they have to either heat up in an oven without CO2 or in heated blocks. And again, it's very important that you control that temperature so that once you start using it, it actually mimics the temperature that you would have had in the dish from the oocytes or the embryos that you are going to place into that media. Fridges and freezers, I find are often neglected. People spend so much time on incubators and heated stages that they kind of forget the importance of fridges and freezers. You spend a lot of money every month on buying culture media, and the place where they stay for the longest period of time is in fridges and freezers. So again, one of the very important places that I think we should place emphasis on to do correct measurements. And then also ambient temperature is quite often, it's maybe not one of the most important ones to measure, but it's something that labs do as well. And then pH, one of the other measurements we take, again, most importantly in our culture media, and in some instances people also look at the changes that pH can have in their buffer medias if they work at certain temperatures. But I'll get back to that in a short while. Other direct measurements that people may take are, for instance, humidity in both the incubators and ambient temperature. The reason I brought this up is there are still clinics who work without an oil overlay. So obviously humidity will be a very important part there. From my point of view, I think it is quite a good thing to use an oil overlay on your culture dishes just because of the buffer that it gives you in terms of the temperature changes and also the pH changes that can take place. But there certainly are clinics who still use large volumes without an oil overlay, and certainly for them humidity will be a very, very big measurement to make sure that they have a high enough humidity within the incubator. And then air quality, whether that's particle counts, VOCs. Within air quality, it's an interesting thing. In the IVF community globally, we find that there's different rules and regulations in different countries, different parts of the world. And certainly within the European Union, you find that there's the EU directives and a lot of emphasis on air quality and particle counts and quality of air. And that might not be the instance in, for instance, somewhere in China or in Africa or the Middle East. So it's important to consider that as well in terms of why will we measure this? Is it dictated by law or by regulation, or is it something that we do for ourselves to be ISO certified or to achieve a certain level of quality within our laboratory? The other thing that we can measure as well, so those are all kind of direct measurements. If we look at indirect measurements, referring to our incubators as well, something like door openings, it is a measure of quality control. If you have too few incubators and it transpires that you open every incubator so many times during the day, you probably need to think, well, how can I alleviate the situation? How can I make things better for my embryo quality? In terms of the door openings, that's not the only thing, because recovery time will be affected. A lot of people look, for instance, at the performance of the incubators. So they actually compare the fertilization rate, cleavage rate, blastocyst rate for each individual incubator. And that gives them an indication, again, of the quality that they can achieve. Now, these are not, as I said, direct measurements, because you have to wait a while to get these results in order to find out how you will eventually act on the situation. Another thing that people look at with these incubators, for instance, will be how often do alarms go off? Do we need to service these incubators? Do we need to replace them? Is it something that happens during the evening hours when we are not in the lab? So a lot of things that we can check there. Air quality, other things that people would also measure, for instance, is bacterial swabs, growth plates that they might do in the laboratory to see if there is any bacterial contamination. Also swabs within the incubators. These are some things that might not be particular for your lab, and I think it bears reference to, for instance, our air quality. If we are able to control our air quality in a very good way, then maybe none of these will be necessary. So again, it's very, very lab specific. Temperature mapping within our incubators and our fridges and freezers. I've already mentioned about the incubators and the fridges and freezers. People find that, for instance, in a large box incubator, they will limit it to only 3 patients. And for instance, they will find a second and a third best position within the incubator to use. And they wouldn't use the rest of the incubator. And that will depend on the type of quality of embryos or the pregnancy rate that they achieve from those specific spots. Now, this is probably more common in your large box incubators. When you have your benchtop incubators, smaller chambers, it's probably less likely that you will get all of this variation. But again, I'm trying to emphasize the fact that it is very lab specific. I can't say that this is how you do quality control. I'd rather want you to think of the bigger picture and see what fits correctly within your laboratory. And equally with fridges and freezers. Where is the best temperature for storing this media? You quite often find that a lot of laboratories have these, let's call it kitchen-style fridges. They don't spend a lot of money on the fridges that they keep the media in. And what happens is there's the cooling element is at the back of the fridge. So therefore, there's always a gradient from the door towards the back. And when you open the door, you tend to get warm air coming in. So there's always that change. And that'll also depend on the opening times. How busy are we? Do we have a small fridge freezer that we work on a daily basis? And do we have a large storage freezer or fridge where we can keep our media on a long-term basis? Now, the measuring devices, what do we use today? Now, in terms of thermometers, there's certain coins as we know them, the temperature coins, there's temp tracers. These are all types of equipment that people use nowadays in the lab. I have an example here of a very primitive and basic type of thermometer. And you need to ask the question, is this really specific enough? Is this going to give us a good enough indication of what we want to measure? CO2 analyzers is something that we do nowadays a lot, where you can just plug it into the back of the incubator, again, depending on the type of equipment you have. pH meters is quite often used. One of the things that is actually a very reliable method is blood gas analyzers, but they are quite expensive. They are quite large machines. You can't necessarily have them in your laboratory. And you quite often find that laboratories that are based inside large hospitals have access to this type of equipment, and they can then very easily measure the pH on these blood gas analyzers. Nowadays, you get also portable blood gas analyzers. Again, probably a little bit more expensive for your regular laboratory equipment to acquire, but it is something that you could potentially make use of on a contractual basis, and then get a better understanding of the pH in your laboratories once your incubators are set. Particle counters, VOC meters, these are all additional equipment that is probably not that common in every laboratory. But I would say definitely your thermometers, CO2 analyzers, and or pH meters. Those top three are the basic ones. Again, I've put the picture here of the pH paper, the strip. Believe it or not, there's still labs that actually use this as an indicator of the pH in their media. Of course, it does indicate pH, but we need to think about the narrow ranges in which we're working. And again, is this effective enough? Is it really going to show us what we want to do to get a proper quality control and quality assurance? Now, looking at who does the measurements and how do we do it? Now, the first point I made there is if you take a lab manager or a lab director, and I speak from experience because I worked my way up as well, you know, from a trainee embryologist and then embryologist, and you finally get to a point where you actually spend a lot less time in the lab and a lot more time in front of the desk, in front of the computer, meetings, reports, and you find that you might get in the lab 2 days a week or something like that. And then you need to start asking the question, who is better to do these type of measurements? The people that are in the lab every day, that have their ear on the ground, that see what's actually going on, that get enough practice with everything that they do? Or is it the people who actually forgot the combination to the lab door and need to call to, can you please let me in? So jokes aside, it's something that we need to consider as well. Who is most appropriate to take these measurements? I think it's a good thing for everybody to have a good understanding and are able to do these type of measurements. But it's also quite important in a good quality control program to have somebody that is responsible for these type of measurements and know exactly how each piece of equipment works, how the probes work, how the cables are connected, these type of things. Because it's not necessarily something that everybody would know in the laboratory. Now, following the protocol is, you know, probably one of the most important things in our day-to-day work as an embryologist. And that also accounts for when we do measurements. We need to set up a protocol on how to do a temperature measurement, how to do a CO2 measurement or pH measurement. That's very important. And not just willy-nilly, you know, tell somebody, oh, can you please measure the pH? There's the instruction manual, just have a look and see how you do it. No, we have to have specific protocols and follow them to the T. And just highlighting there the fact that we need specific equipment. I alluded to that in the previous slide, that we have to find something that's specific enough for the measurements that we want to take. Just briefly about the frequency, you typically now have a lot of laboratories where there's continuous monitoring, where they have a system in place where you can regulate temperature, pH, a lot of these measurements continuously, particle counts even. So you get an electronic measurement every 5 minutes, every 10 minutes, however regularly you set it. Or you may have to make use of once-off measurements. So decide every morning we do all of these measurements, or once a week we do these pH measurements. And again, these are just indications or examples. Every lab will be different depending on the type of work that they run in the laboratory. I'm just going to highlight a few of the measurements that we take. In terms of the CO2 measurements, I think most of us are familiar with these analyzers that you, as I said, plug into the back of the incubator and you read the measurements. It's quite an easy, direct method. Even if you have larger type of analyzers or VOC meters, air quality counters, there's a lot fewer variables to contend with. So it's a very easy measurement, not many mistakes to make. Now, a lot of labs still make use of pH meters, and they measure the pH maybe quite regularly, maybe once a week, maybe every time there's a new batch. Now, they are very, very good measurements if they are done correctly. I always believe that when you look at biochemists, they are very well qualified to do pH measurements because that's what they do, that's their food. An embryologist, maybe we're not that great with pH measurements because it's not necessarily something we do on a daily basis and we don't know exactly how everything works. There's a lot of variables that can influence the outcome, and also there could be operational errors between different people that make use of the equipment. An example I have of that is we actually did an experiment within Vitrolife where within Sweden we sent out a batch of media to I think 5 different clinics within Sweden, and these clinics are renowned for taking pH, so they feel very confident about taking the pH. We have sent it to them and they've sent back the results, and what we got back is 5 different sets of the results. Now, if everybody was very good and very proficient at pH measurements, then, and there wasn't a lot of variables, then we should have got one answer. But the fact that we got different answers just indicates the variability that can take place. And what typically happens, as soon as people see a change in the pH, they change the incubators. Now, then you need to ask the question, what are we measuring? Are we measuring the media or are we measuring the incubator? So it can be a bit tricky. As I said, if it's done correctly, it's a very, very powerful tool. But think about the things that can potentially go wrong. In terms of temperature measurements, again, make sure you have the right equipment. You see some strange things when you visit labs. The little picture here of the duck, there's actually a lab that had something very similar when they transported their IVF tubes from one lab to another, and they had it wasn't a duck, but it was something very similar to indicate the temperature is okay within the sample box. Well, I have my doubts. So you have to make sure you have the right equipment. We typically make use of these mercury bulb thermometers. They're very common to have as an additional layer inside your incubator or inside your heated blocks. But more commonly, people make use of an electronic display thermometer with a thermocouple and a sensitive probe. Again, these things we need to research. We need to find out, are we using the correct probe for the measurements we want to take? And I'll talk about that in a little while. Very importantly, when we measure temperatures, we're not interested in the temperature on the stage. We're interested in the temperature in the media where our embryos will be grown. So again, we need to mimic the conditions that we are measuring. So specifically, if we work in a large volume or if we work in a droplet, mimic those conditions so that you have the right type of measurements that you take. Now, just a few things about temperature measurements, and I've seen this a lot when I've gone around to different laboratories. Down here is an example of measuring temperature in droplets, for instance. And you can either have a very small area exposed to, that's the oil overlay, and that's our droplet, a very small area exposed to the oil and the culture media. Now, this will typically, when you take it out of the incubator, be more or less at 37 degrees Celsius, and the rest will be ambient temperature. Now, you can see the difference in this probe. You have a much larger surface area that's exposed to this 37 degrees Celsius environment. And if you take the reading on these two, they will be completely different, even though the tip of the probe are both inside our droplet. The length of the thermocouple will actually have a big influence. The length that's inside the 37 degrees Celsius area will have a big influence on the reading. So that's quite important. The hand position within the thermocouple, we've seen that's different as well. So if somebody uses or holds it very close to the tip compared to somebody holding it further away, again, you will get different measurements. And the type and the age of the thermocouple will also depend. It needs to get serviced, it needs to get replaced within certain times. And these are just a few things that you need to think about. And it comes back to what I said before, follow the protocol. There should be a specific protocol. If you have two different people doing temperature measurements and they do it the same way, you will get different readings. Even though the equipment has not been changed, you will get the different readings, and then people may act and change the temperature settings based on the operator or the parameters that have influenced our measurements. So just a few things to think about there. Other factors that can influence our temperature measurements as well, airflow, whether it's switched on or switched off. Again, I can't emphasize enough, if you are doing any type of measurement, you have to mimic the conditions that you will work under. There's no point in waiting until the lab is shut down and then say, oh, we quickly need to measure this, just take a dish out, measure it, oh yeah, it's fine. So exposure time to the actual droplets or the measuring area is very important. The distance from the incubator to the workbench. If your incubator is on this other side of the wall and you have to walk from there to the workbench and do the measurement, then that's what you have to do. It's definitely not ideal. You probably want to be closer to where you work. But it's no point in doing the measurement right there, because the distance from there to there will completely influence the temperature inside your dish. So again, mimicking those conditions. The type of dishes that we use, if you are using a specific center well dish, then you have to measure that center well dish for that specific procedure. You can't take a center well dish and put it on an ICSI stage to validate your ICSI measurements because it's not an ICSI dish. And you probably know that all of these different dishes have different heights above the heated stage, and therefore the air gap is different. And that can then influence our temperature as well in terms of the amount of air that's trapped as soon as you put the dish down. So very dish specific. And I already mentioned about the time of the day. Do it again to try and mimic the conditions that you will have. If you have a full lab, busy, the adjacent operating theatre is being used, so there's air coming in and out from there, there's people moving around. That will be completely different conditions to when you're at the end of the day and everybody is left and there's no work being done. So think about these things as well. They might not always be practical, but you need to find the best way of doing these measurements. And yeah, just emphasizing again the fact that we need to find those same conditions. And then eventually, what do we do with these results? We do these records. We either have paper copies or electronic copies, especially in terms of the continuous monitoring systems. And I have seen labs where you walk in and you probably can't even walk through the door because there's just shelves of filed temperature measurements. And then you ask them, okay, so what do you do with these? They say, no, we file them. Okay, and does it give you any information? So yes, we need to do something about them. We are either going to action it or at least review them on a yearly basis or a 6-monthly basis and see, are there any indication? Do we see any trends within the equipment that we are using? Have we seen changes in terms of different people that are doing these measurements? So do something with them so that you can eventually interpret them and then take an action and decide, right, equipment needs to be serviced, equipment needs to be thrown away, people need to get fired. No, not that. But you need to decide how's the best way to work it and then actually do something with these results. So, as a summary, we need to first of all determine what measurements are we taking. And as I said before, that is quite dependent on the law, regulations within certain laboratories, and the ability within those laboratories, the size of the laboratories, the number of cycles you run, the amount of people that you have in the laboratory, and what is necessary. We need to use the appropriate equipment, whether that's for temperature measurement, CO2, pH. Make sure that you have something that gives you an accurate information. If we look at pH, for instance, we typically work between 7.2 and 7.4. If you don't have something that can measure that small, then you need to think, well, is it worth using it? Be consistent, so follow the protocol, and then take the right action, make the right decisions when you have analyzed this data so that you can actually have the QA and QC work for you. There's no point in just doing it. You have to eventually have something that you can do with it. I thank you for your time.